Hi everyone, in this video we are going to start learning about the third algebraic identity. Okay, the third identity is a minus b into a plus b, and as Hi everyone, in this video we are going to start learning about the third algebraic identity. The identity is a minus b into a plus b. In the previous videos, with the respect to first two identities, we had learned about their proofs, expansions and factorization. So likewise, in this also, we are going to learn the same kind of things for the third identity. Okay, so let's start. The identity is, as I said earlier, a minus b into a plus b, right? Regarding the proof, so let's start with it. When we talk about proof, we just write the identity and we expand like a binomial into binomial, right? So let's start with it. First, we are going to multiply a with a, and that gives us a square. Then this a with the b, and that gives us plus ab because both were positive. After that, minus b with a. Now one term is negative, so we will have minus ba, and lastly we will multiply minus b with b, and that gives us minus b square. Now if you look over here, ab and ba, they both are like terms, just the order is different, but one is positive, the other is negative. So what we will have now, they will get cancelled. They are like positive and negative, therefore they get cancelled. So what are we left? We are just left with a square minus b square. So when we talk about the third identity, it is a minus b into a plus b. It always results in a square minus b square. Basically, you can understand this identity also as the sum of two terms into the difference of two terms, and it results in the square of the first term minus the square of the second term. Because you will see various kind of quotients, this identity has plenty of quotients, okay, and you need to master this one very carefully. Now let's start with expansions. The first quotient being 2x plus 3y into 2x minus 3y. When we talk with respect to expanding about the third identity, the quotients are pretty easy. They are pretty direct and easy, because we can easily see them that yes, in one bracket we have positive between the terms, and in the second bracket we have a negative between the two terms. So we can identify very easily that yes, it is going to be a square minus b square. Okay, so applying that, when we talk about a square, now this is a plus b and a minus b. That means my a is 2x over here and b is 3y. So writing with respect to a square minus b square, it gives me 2x whole square minus 3y whole square, right? So 2x whole square means we have to square 2 and x both. So square of 2 is 4 and square of x is x square. Now similarly we need to square 3 as well as y. So the square of 3 becomes 9 and square of y becomes y square, getting us our answer, that is 4x square minus 3y square. It was easy, right? Now similarly the next one is also pretty easy, where we have 5 over 2 as our a and y as our b. So we have a minus b in the first bracket, and in the second bracket we have a plus b. Okay, over here since we are multiplying, it doesn't matter whether we are writing sum first multiplied with the difference or we are writing difference multiplied with sum. The answer is going to be absolutely same, right? So starting with its expansion, we have 5 by 2 whole square minus y square. Now whenever we have got a square of a rational number, you need to square the numerator as well as the denominator. So square of 5 is 25 and square of 2 underneath is 4, and the y square remains as it is. So the answer becomes 25 over 4 minus y square. Okay. Now coming to the last question over here. We have p square minus 0.5 into p square plus 0.5. Now we can see that we have square already over here, but still the identity remains same, because whichever power you have on any of the variable, it doesn't matter. Now the thing that will change over here is just that your p square will become a, so it is a minus b, because 0.5 is a b. And similarly in the next bracket, p square is your a and we have a plus b. Now the identity says a square minus b square. So what is going to be a? It is p square, but I have written a. We need to write a square. That means a square will go out. Minus 0.5 square, because b is 0.5, right? So what is the square of p square? The powers will get multiplied using the exponential law, which is an outside n. They both are getting multiplied. So 2 and 2 gets multiplied, giving us 4. So therefore we have p to the power 4. And now what is the square of 0.5? It is 0.25. Therefore the answer is p to the power 4 minus 0.25. I hope it is clear. Because the expansion, when we are talking about this identity, the expansions are actually easy, right? Now moving on further, we have a question over here which says find the value of, and we have 3 parts on the screen. The first one being 55 square minus 45 square. So now we are given in the form of a square minus b square, right? Okay, this identity is equally useful whether we are talking about from a minus b into a plus b to moving on to the other side, which gives us a square minus b square, or the vice versa, means you have a square minus b square and you get the other form, which is a minus b into a plus b. And on this page only we will see that how to use either of the forms, right? In the first question we have a square minus b square. That means we need to move to the other form. From a square minus b square we are going to get a minus b into a plus b, and this means we have a square minus b square. So what is my a? A is 55 and b is 45, right? It should give me a minus b into a plus b, right? I'm just substituting the values now. A is 55 minus 45. In the next bracket, 55 plus 45, right? So what is 55 minus 45? That is just 10. And what is 55 plus 45? That is 100. So what is our answer? It is 1000. Guys, this identity is so useful. You can use that in various kind of calculations where you have a difference of squares. You will get to see that. You will be using that in surface area volume of class 9. You will use that in few questions, and then you will realize it's important in class 10th also, that how actually you can bring this identity into practical usage for saving on to your calculations. Okay. Now with the second part. Second part says 10.5 into 9.5. Okay, now we do not have any squares, right? So how to understand that yes, we need to apply the third identity. That's true that just by looking at it, it becomes little tricky to understand. But if you realize what we have over here is, we have the form of a plus b over here and then a minus b. I'm sure you must be thinking while reading this question that what is a and what is b. A is 10, b is 0.5, because when you subtract 0.5 from 10 you get 9.5, and when you add 0.5 to 10 you get 10.5. So now over here when we apply this identity, the calculation will again become easier. Let's see. Now we have a plus b into a minus b given, so we should be having a square minus b square on the right? Substituting it, what I get, just a second, yeah, we should be having, now what I said, we have, let me just rewrite it, right? I am writing it now, 10 plus 0.5 into 10 minus 0.5. I have just elaborated it so that you understand what is our A and what is our B. Okay, now it should give me 10 square minus 0.5 square, because A square minus B square. So what is 10 square? 100. What is 0.5 square? 0.25. Now if you subtract 0.25 from 100, the answer is 99.75. I did not use any calculator, neither did I do any calculations on the side, but subtracting 0.25 from 100 was pretty easy than actually multiplying 10.5 and 9.5, right? So do practice such questions well. Now moving on with the third part. The question says 1.02 square minus 0.98 square. We can see easily we have the form of A square minus B square, right? So what we need on the right? We need A plus B into A minus B. And what is my A? A is, okay, we have A square minus B square, right? So what is our A? 1.02 and plus 0.98. This is what we get in the first bracket. The second bracket gives us 1.02 minus 0.98, right? Now add them, and guys, when we are doing these questions, try to get into the oral calculations. The more you do your calculations mentally without writing, the faster you will be. Okay, so 1.02 plus 0.98, it gives you just 2, because 9.98 is 0.02 less than 1. That is already covered in the first number, so we get 2, right? Now this is the answer of the first bracket. What is the answer of your second bracket, which is 1.02 minus 0.98? It is a difference of 4 units. 2 increased, 2 decreased, so it is 0.04, because we have 2 decimal places, right? Now just need a final multiplication of 4 into 2, which is 8, and how many decimal places? 2. That means our answer becomes 0.08. I am sure that you must believe that the calculations were so easy when we applied the third identity, be it any question on this screen. The first, second, third calculations actually turned out to be easier using this identity. Okay, now moving on with factorize. Okay, when we talk about factorization with respect to the third identity, there are enormous questions that exist in the books, right? Lot of questions, because now this identity actually gets clubbed with the previous 2 identities also. And over here, while doing these questions, you will see that what can be the variety that exists. Now the first question, I have picked the first question for factorization, which is pretty straight. We are given 6.25 m square minus 2.25 n square. So what do we have over here? We have A square minus B square, right? The factors have to be of the form A plus B into A minus B. We can understand my A. What is our A? It has to be the square root of 6.25 m square. First of all, what is the square root of 6.25? It is 2.5, right? Because 6.25 had 2 decimal places, so the square root should have only 1 decimal place, and the square root of m square is m, right? Then what is the square root of 2.25? 1.5, and the square root of n square is n, right? So we get the first bracket as 2.5 m plus 1.5 n. So we will get the second bracket also, which is 2.5m minus 1.5n, right? And that is the answer, because we have already got the factors a plus b into a minus b. It was the easiest application of this identity while factorizing. Okay. Moving on with the second part. Now, we have 3a square b minus 243ab cube. Can you see the identity over here, which is a square minus b square, and directly applied over this? No, right? But we can see that there are some common elements that exist. Because see, when you had started learning factorization in class 8, taking out common factors was the first step taught before you learned the identities. Okay, and taking out common factors will always be going to be an integral part of factorization, be it whichever identity. So over here also we are going to first find out common factors. And what is the common factor? I can see 3 is a common factor because the first term is divisible with 3. The second term, having 243, is also divisible with 3. And along with that, I can see we have a and b also as a common factor, right? So let's start with it. What we are having over here as common factors is 3, a and b. And when I do that, what are we left with? Just a moment. The quotient has to have a cube b, right? So now when I take out ab as a common factor, what are we left? 3 gone from the first term, a gone from the first term, leaving us with a square, and then b also gone. So we are just left with a square in the first term. Now, when you divide 243 ab cube with 3ab, what are you left with? Because why I am dividing? Though we were taking out common, because taking out common elements is nothing but a kind of division. And when you divide 3 with 243, you get 81. So I write 81 over here. And then when you divide AB cube with AB, A got cancelled and we are just left with B square, right? So we have done the first step where we took out the common factors. Now the elements that we are left inside is a square minus 81 b square. Now we have actually reduced this bracket expression actually in terms of a square minus b square, or now I should say actually x square minus y square. And now why I am using x square minus y square? Because x, a and b are already being used over here. So that means a is my x and over here it is my 81b square is my y square, right? So let's continue. 3ab remains out. We need to expand in the form of a minus b into a plus b. What is a now? We have to write square root of a square, which is a. Then what is the square root of 81b square? For 81 it is 9, for b square it is b. So therefore the second factor becomes a plus 9b, and now the third factor, it is a minus 9b. Why did I use the term, why did I say second factor and the third factor? Because 3ab turns out to be my first factor, right? A plus 9b turns out to be the second factor, and then lastly a minus 9b turns out to be the third factor. We are multiplying, the order doesn't matter for the factors, but I just wanted to show that you are getting 3 factors over here: 3ab, a plus 9b and a minus 9b. I hope this question is clear. Okay. Now the next part, we have 3a plus 5b whole square minus 4c square. What you can see in this question, there are 2 ways to do it. Okay, and the 2 ways are, if you start by applying the first identity in the first bracket, that is a plus b whole square. Then you will expand it, and after that you are left with 4c square. But we will not be able to factorize it. We can simplify that using that method. However, for factorization, you have to use the third identity over here. So when we are using the third identity, basically 3a plus b, 5b becomes your x, and 4c actually becomes your y square, x square and y square. Okay, now we need to have x plus y into x minus y, right? So what is going to be your x? It has to be the square root of 3a plus 5b whole square, and thus we get 3a plus 5b. After that, what is y? Y is 2c, because square root of 4c square is 2c. Okay, so first bracket gives me 3a plus 5b plus 2c. Now second bracket, 3a plus 5b minus 2c. Can you see that do we have any scope over here where we can simplify further within the brackets? No, we are in the most simplified form while we have factorized. So that means this is your final answer. I told you earlier, when we start with the factorization of the third identity, we will see that how it starts clubbing the previous identities along with. And this is one such example where it was clubbed with the first identity, but since we were factorizing, we didn't apply the first one. Okay, moving on with the fourth. We have x to the power 8 minus y to the power 8. Now you will see, and you will say actually that it doesn't look like the third identity because we do not have anything for squares, and neither we have any scope for your first or the second identity. I agree. What we need to do over here is we have to break this 8 into simpler numbers. Simpler numbers mean I can write x to the power 4 whole square minus y to the power 4 whole square. 8 means 4 into 2, so I just used factors of 8 as 4 and 2, and then I used the exponential rule, a to the power n, and outside n I used this one, right? Now I am sure you must have realized that now it actually appears to be a square minus b square, where your a is x4, your b is y4, right? So we get x4 minus y4 into x4 plus y4, because what we did a minus b into a plus b. So tell me now, are we done with this question here? No, we are not done, because it can be factorized further. Yes, it can be factorized further. We can rewrite this as x square whole square minus y square whole square, and now I am using a square bracket separated with the other factor, which is x4 plus y4. And guys, the second bracket, which is x4 plus y4, cannot be broken further, as we do not have any identity for a square plus b square. It is a plus b whole square, or it is a square minus b square. So the second bracket remains as it is. Okay, now applying further the third identity in the first square bracket, what does that gives me? That gives me x square minus y square into x square plus y square into x4 plus y4. And I know now you are done that yes, over here we need to apply it further. Therefore, your final answer is x minus y into x plus y into x square plus y square into x4 plus y4. This question had lots of steps, and I have written each and every step carefully. It needs to be done only in this manner, because this will prove to be your correct answer when you leave it here. Okay, now moving on with the next question. Okay, now the last question for this factorization I had picked quite a few examples for this identity because, as I said earlier, it has a lot of variety. I wanted to showcase the different variety of questions so as to give you exposure. Okay, now what we have over here, 2x plus 1 by 3 whole square minus x minus 1 by 2 whole square. I know looking at this question, many children actually get so inclined that ma'am, we can apply a plus b whole square over here and a minus b whole square over in the second bracket. I agree. But that needs to be done when you are simplifying. We are not simplifying. We have to factorize, right? And that expansion from the first and second identity over here will simplify your answer, but it will fail to give you factors. So over here you have to factorize, and thus you have to apply the third identity, which means this whole expression actually becomes your x, and this whole expression, second expression, becomes your y. I know when you are actually talking to a maths teacher, this and this is a very common habit. So I am also used to that. Now 2x plus 1 by 3 is your x and x minus 1 by 2 is your y. So expanding, that means I need to write now x plus y into x minus y. What is x? X is 2x plus 1 by 3, right? And what is y? It is x minus 1 by 2. Okay, what I have done, I have added up the two elements. Now the second bracket, 2x plus 1 by 3 minus, okay, now we have to find the difference of the two expressions. So I am going to use an internal bracket over here because the minus outside will actually help me changing in the sign, right? We need to simplify this further. It cannot remain just like this. 2x plus x is 3x, then 1 by 3 minus 1 by 2. We need to do this. Then we have 2x plus 1 by 3. Opening up the internal bracket leaves me with minus x, and this minus minus becomes plus 1 by 2, right? So 3x. Now we will take the LCM of 1 by 3 minus 1 by 2, which you can do easily. So 2 minus 3 is minus 1 by 6. My first bracket gives me 3x minus 1 by 6. In the second bracket, it is 2x minus x, that is x. Then we have 1 by 3 plus 1 by 2, that is going to be plus 5 by 6. Now, what do you think? Are we supposed to simplify anything further? Or is it the final answer? Have we got our factors? Yes, we are done with it. Because 3x minus 1 by 6 we cannot simplify. X plus 5 by 6 we cannot simplify anything further. So these are our final factors. In this video, we understood the third identity in great detail, that is by first understanding its proof, doing the questions on expansion, finding the value, and then covering a lot variety on factorization. Do try to practice on each and every question on your own after looking at the video, and if you have any doubt or want further clarity, you can always comment and I'll reply to it. Happy learning!